There is a quiet lesson hidden in the vastness of our solar system. Two worlds can appear almost identical from a distance, yet hold remarkable differences that challenge everything we think we know. Uranus and Neptune are often called sister planets because they are similar in size, composition, and structure. For many years, people believed they were nearly twins, separated only by distance from the Sun. But one mystery has continued to fascinate astronomers and space enthusiasts alike. If these planets are so similar, why is Neptune a much deeper, richer blue than Uranus? The answer is more than just a matter of color. It is a story of invisible forces, mysterious atmospheres, frozen clouds, and discoveries that remind us how little we truly know about the universe. Every planet has its own identity, shaped by millions or even billions of years of cosmic history. Just because two worlds begin with similar ingredients does not mean they will become the same. For decades, telescopes showed Uranus as a pale blue-green world, while Neptune appeared as a vivid sapphire sphere glowing against the darkness of space. Scientists originally believed the difference might simply come from camera technology or the way images were processed. Others suspected that Neptune contained more methane gas, since methane absorbs red light and reflects blue wavelengths. While methane certainly plays an important role, it turned out not to be the complete explanation. As technology improved, researchers examined the atmospheres of both planets with incredible precision. They discovered that Uranus and Neptune actually contain very similar amounts of methane. This surprising finding created an even bigger mystery. If methane levels were nearly the same, why didn't both planets display the same brilliant shade of blue? The answer slowly emerged through years of careful observation and advanced computer models. Scientists found evidence that the upper atmospheres of these planets behave. The mystery of the sister planets. Uranus and Neptune are called sister planets because they are similar in size, composition, and structure. Despite these similarities, Neptune appears much deeper blue than Uranus, creating one of the solar system's most fascinating mysteries. Uranus and Neptune have fascinated scientists for decades because they appear to be cosmic twins separated by distance, yet they display a surprising difference that is impossible to ignore. Both planets are classified as ice giants and share similar sizes, compositions, and atmospheric elements. They are made mostly of hydrogen, helium, and methane, with deep layers of water, ammonia, and other icy materials hidden beneath their clouds. However, when we look at images of these distant worlds, Neptune shines with a powerful deep blue color, while Uranus appears much lighter with a pale blue-green shade. This difference created a major mystery for astronomers. If both planets formed from similar materials and have almost the same atmospheric ingredients, why do they look so different? For many years, scientists searched for answers by studying their atmospheres, sunlight reflection, and chemical compositions. The mystery revealed that planets are not defined only by what they are made of, but also by how their environments change over billions of years. The contrast between Uranus and Neptune shows that even neighboring worlds can follow completely different paths. Small variations in atmospheric conditions, weather patterns, and internal processes can transform the appearance of an entire planet. Their story reminds us that the universe is filled with hidden details waiting to be discovered. Methane wasn't the whole answer. Scientists once believed Neptune's darker blue color came from having more methane gas. However, modern observations revealed that both planets contain nearly the same amount of methane, leading researchers to search for another explanation. For many years, scientists believed they had solved the mystery of Neptune's deep blue color. The most obvious explanation was methane gas, which exists in the atmospheres of both Uranus and Neptune. Methane absorbs red wavelengths of sunlight and reflects blue light back into space, making these planets appear blue. Since Neptune looked much darker and more vibrant, researchers assumed it must contain a greater amount of methane compared to Uranus. However, further studies revealed that the difference in methane levels was not large enough to explain the dramatic contrast between the two planets. This discovery created an even bigger mystery. If both planets have similar amounts of methane, then something else must be influencing their colors. Scientists began examining other possibilities, including the structure of their atmospheres, the movement of clouds, and the presence of tiny particles floating high above their skies. Advanced observations and computer models eventually showed that atmospheric haze plays a major role. The way light interacts with these tiny particles changes the appearance of each planet. Neptune's atmosphere allows more of its deep blue color to be visible, while Uranus has additional layers that make its color appear softer and less intense. This discovery proved that planetary appearances are shaped by many complex factors, not just a single chemical ingredient. The mystery of these sister planets revealed the incredible complexity of worlds beyond Earth. The role of atmospheric haze. The biggest difference lies in their upper atmospheres. Uranus has a thicker layer of haze that scatters sunlight and gives it a pale blue-green appearance, while Neptune's thinner haze allows its rich blue color to shine through more clearly. The atmosphere of Uranus and Neptune plays a major role in creating the difference between their colors. Although both planets contain similar gases, including methane, their upper atmospheric conditions are not exactly the same. Scientists discovered that Uranus has a thicker layer of haze made up of tiny particles floating above its clouds. This haze acts like a filter, changing the way sunlight is reflected and making Uranus appear lighter, with a soft blue-green color rather than a deep blue shade. Neptune, on the other hand, has a thinner layer of atmospheric haze, allowing more of its natural blue color to be seen. Without as many particles blocking or scattering the light, Neptune appears much darker and more vibrant when viewed from space. This difference shows how even small changes in a planet's atmosphere can completely transform its appearance. The formation and behavior of these haze layers are connected to complex processes happening within each planet. Temperature differences, chemical reactions, and atmospheric movements all influence how particles form and remain suspended in the sky. By studying these differences, scientists gain a better understanding of how planets evolve over time. The contrast between Uranus and Neptune proves that a planet's beauty is not only determined by what it contains, but also by the invisible forces shaping its atmosphere. Weather shapes their appearance. Neptune experiences powerful storms and the fastest winds in the solar system, which help clear or redistribute haze particles. Uranus has a much calmer atmosphere, allowing haze to build up over time and soften its natural blue color. Neptune's powerful weather system is one of the biggest reasons it looks so different from its sister planet Uranus. Despite being much farther from the Sun and receiving very little solar energy, Neptune has one of the most active atmospheres in the entire solar system. The planet experiences enormous storms, rapidly changing cloud patterns, and the fastest winds ever recorded on any planet, reaching speeds of more than 2,000 kilometers per hour. This extreme weather creates constant movement in Neptune's atmosphere. Powerful winds and storms help move, break apart, and redistribute the particles that create atmospheric haze. As a result, Neptune's deeper blue color becomes more visible because fewer haze particles block the light coming from its atmosphere. Uranus, in comparison, has a much calmer atmosphere. Its weaker weather activity allows haze particles to remain in the upper atmosphere for longer periods. Over time, this creates a thicker layer that makes the planet appear lighter and less colorful. The difference between these two worlds shows how important weather can be in shaping a planet's appearance. The contrast between Uranus and Neptune teaches us that planets are constantly changing environments, not just silent objects floating in space. Their storms, winds, and atmospheric movements play a major role in creating the unique identities we observe from Earth. Even distant worlds with similar beginnings can develop completely different personalities over billions of years. A reminder that similar worlds can be different. The story of Uranus and Neptune teaches that even planets with similar origins can evolve in very different ways. Their unique atmospheres, weather systems, magnetic fields, and history show that the universe is far more complex and fascinating than it first appears. The story of Uranus and Neptune teaches us that similarity does not mean sameness. These two planets may have formed from similar materials in the same region of the solar system, but billions of years of different conditions have shaped them into unique worlds. Their contrasting colors are only one example of how small differences can create enormous changes over time. Beyond their colors, both planets contain many mysteries that continue to challenge scientists. Their unusual magnetic fields, extreme environments, and hidden internal structures reveal that the ice giants are far more complex than they first appear. Deep beneath their thick atmospheres, scientists believe there may be oceans of water and other strange materials under incredible pressure. These hidden regions could hold clues about how giant planets form and evolve. The difference between Uranus and Neptune reminds us that the universe is full of unexpected discoveries. A small change in atmosphere, weather, or chemistry can completely transform the appearance and behavior of a planet. What looks simple from a distance can become incredibly complicated when explored more closely. By studying these distant worlds, scientists are learning that every planet has its own story written through time. Uranus and Neptune are not just blue planets in the outer solar system. They are examples of how nature creates endless variety across the cosmos. Their mysteries inspire curiosity and encourage humanity to continue exploring the unknown.